how not to run machine learning in production. What are some of the challenges that companies face? What are some of the problems that organizations are seeing today that you can avoid? You can avoid those pitfalls, and what are some of the solutions? On that's what the agenda is going to be today: how not to run machine learning on production. So let's look at the production machine learning landscape for a minute. Many companies start with setting up their machine learning infrastructure either on premise, so they'll buy a lot of CPUs, GPUs, kind of hardware accelerators, hardware servers to run machine learning training on premise, or they will set up a sophisticated cluster on the cloud, either a Kubernetes cluster or a Spark cluster. But essentially, they will pre-provision some infrastructure on the cloud to run their machine learning training and prediction jobs. Now, nothing wrong with that. Companies have been doing that. I know large corporations who are doing that and doing that successfully. And we have seen that time and again. But there are definitely better ways of doing stuff. And that's what we are going to talk about today. So what happens when you go the traditional route and pre-provision some infrastructure for running machine learning either on premise or on cloud? One of the two scenarios happen. Either your machine learning infrastructure is underutilized or you're not able to scale. When I say your machine learning infrastructure is underutilized, imagine that you have a team of data scientists that is running ML training jobs throughout the day whenever they are working and they're running experiments, but your infrastructure is still not utilized 24 hours in a day. Imagine if there's nobody working at night or there are no jobs running at night and you're not utilizing your infrastructure for about 8 hours at night. Even then you're paying 50% more than what you are utilizing throughout the day. And on the other hand, there might be a scenario where you are utilizing your hardware or your infrastructure 100%, but then you hit the limits every time you hit 100% because you're not able to scale and get more capacity instantaneously. You need to go through another provisioning cycle. You need to spend time on it, and which is a good problem to have, which means that you're scaling, but then you're not able to scale fast enough because you're limited by the scale of your existing cluster or existing infrastructure. So that's what we are going to address today. How can you not have resource wastage by underutilizing your hardware, or how can you make sure that you're able to scale with the growing needs of infrastructure for machine learning? And for that, I would like to present two solutions by Google Cloud Platform. One of them is called the AI Platform, which will enable you to run on-demand machine learning training jobs. And the other one is deep learning VMs on Google Compute Engine, which are pre-configured environments that give you a head start with fully configured virtual machines for popular deep learning and data science frameworks. So let's look at AI Platform. AI Platform is it's a platform for running serverless training jobs on GCP. You can containerize your machine learning training code, and then you can just upload that Docker image on Google Cloud Storage and pass the path of that Docker image into the AI Platform training console. All you need to provide is the container image of your training job and your data, and the AI platform will figure out how much infrastructure needs to be provisioned, what kind of, you can definitely define what kind of hardware accelerators, GPUs or TPUs you need to get your job done faster. But then how soon you want to scale up or scale down, all of that can be left out to AI platform, and you don't have to worry about provisioning or pre-provisioning any hardware. You can also utilize the hyper tuning feature of AI platform, which is an excellent feature to parallelize a lot of experiments and get to the most optimal experiment outputs very quickly, essentially using AI to find the best machine learning model. So once you have trained your model using AI platform, you can also deploy a model on AI platform very easily for prediction. So you can deploy, you just upload the model, the trained model, which is already on cloud storage. You can just deploy it on AI platform, and it will be available as an API for you to start making predictions. So you can make batch predictions, or you can deploy it as an API endpoint for online prediction. Also, you can add hardware accelerators like GPU for faster prediction in case you were doing a very complicated computer vision model or a natural language processing model and you wanted results in real time. Then you should definitely consider a GPU on an AI platform deployment. So this was the first solution, Google AI platforms, serverless training, serverless prediction. So you don't have to worry about pre-provisioning hardware. So you're not wasting any resources. You're not underutilizing any pre-provisioned clusters or hardware that you have capex investment into. And also you will never run out of scale because now you're utilizing Google's scale. You will always have capacity irrespective of how complicated your models are. Let's look at the second solution, which are deep learning VM images. These are pre-configured virtual machine images on Google Compute Engine, GCE. These can be utilized for fast prototyping. Again, they have support for CPUs, GPUs, and TPUs, and so on, and they are performance optimized to run machine learning on cloud. So let's talk about fully managed notebooks on pre-configured environments. So deep learning VMs, one of the products that GCP provides is called AI platform notebooks that run on top of these deep learning VMs. They are pre-configured environments for frameworks like NumPy, SciPy, TensorFlow, Keras, XGBoost, PyTorch, and so on that you can use to write your machine learning experiments. Google AI platform notebooks are quick to start with. There's no learning curve because you're using the same JupyterLab environment that you would be using on your own machines or on your own clusters right now. They are centrally managed, so your DevOps team can get full control, and they have state-of-the-art security built in and authentication built in, so your security teams can be rest assured that you're using top-notch security standards. Like I said, they're one-click deployment. You go into the AI platform notebooks and you select a new instance if you want to start creating an AI platform notebook deployment. You can select which framework you want, TensorFlow, PyTorch, or others, or you can you can select which machine type you want. We have here on the screen standard and standard GPU, but you can actually select any instance type. It is all customizable. You can have any number of cores, any amount of memory, any kind of GPU, and any number of GPUs, and so on. So you can add and remove GPUs as and when you need it. So not only when you're creating the notebooks, but even when you have a notebook live and you want to switch the GPUs and you want to add more GPUs, you can do that. And that's it. Your notebook is up and ready, and then you can start using it. You can scale on demand. You can add more CPU cores, GPU cores, and so on. And the notebook is integrated with all the other products in the GCP environment. So if you have your data in BigQuery, or if you have your data in Google Cloud Storage, it is easily accessible. The data is easily accessible without you having to install any other third-party libraries, and the data is already available in your notebooks. And you can not only train your machine learning models on the notebook itself, but you can use these notebooks to deploy training jobs either on AI platform that we saw previously, or even your on-demand cluster if you're using Kubeflow and Kubeflow Fairing. So this was AI platform notebooks. It runs on Google Compute Engine, like I mentioned, on deep learning VM images. This is a small architecture of how it runs. You have AI platform notebooks that run on deep learning VM images on Compute Engine. It is highly integrated with Git workflow, so you can either use cloud repositories or GitHub to manage the source control on your notebooks. And it is integrated with GCP, so you can read and write data from data sources such as BigQuery or cloud storage and so on. So these were the two examples of services that Google Cloud has to offer: the AI platform notebooks and Google compute engine with deep learning VM images and AI platform notebooks, which will help you to on demand create infrastructure as you need it without having the requirement to pre-provision anything, and make sure that you're not underutilizing your pre-provisioned hardware and you're not hitting the scale every time you want to scale.